Morning friends, in kinetic energy, last video I had the equation of the pressure act on a wall of a container due to the molecule of, because the molecule of a gas perform the random motion. During this random motion, it perform the collision with the molecule and wall of a container. During the collision of the wall of a container, it produced the pressure. We derive the equation of the pressure P is equal to 1/3 rho average V square. After that, we discuss about the VIMS value or the IMS value. What is the definition of IMS value? Root of mean of square value is known as the IMS value. Again, the square root of mean of square value is known as the IMS value. Now, the VIMS, that means the square root of mean of square of speed of a molecule, that is known as the VIMS. Right? And we also derive the equation of VIMS is equal to under root of 3p upon rho from equation of pressure. And also we discuss about that average translational kinetic energy of molecule of a gas is directly proportional to the absolute temperature of a gas. That means the average half m v square, or that can be also written as half m average v square is equal to 3 by 2 kb into d. 3 by 2 is constant, kb is the Boltzmann constant. Therefore, this average translational kinetic energy is directly proportional to the absolute temperature of a gas. Clear that? Okay. After that, today we are going to discuss about that what is the definition of absolute temperature and what are the other equation of VIMS. First, define the absolute temperature. To obtain the definition of absolute temperature, first we write down this equation, the average translational kinetic energy of one molecule of a gas is average half m v square is equal to 3 by 2 kb into t. That is our equation 1. Here kb is Boltzmann constant. T is absolute temperature. M is the mass of molecule. Mass of molecule. And V is speed or the velocity of the molecule. In this equation, as we consider the absolute temperature is 0. So from this equation first, we can write down this half cancel. Therefore, average v square is equal to 3 kBT upon m. 3 kBT upon m. Therefore, taking the square root on both sides, so it becomes the IMS value of velocity is equal to under root of average v square is equal to under root of 3 kBT upon m. If T is equal to 0, absolute temperature is 0. That means the VIMS is equal to 0. Then VIMS becomes 0. Now the definition of the absolute temperature. The temperature at which VIMS of molecule of a gas becomes 0 is known as absolute temperature. The temperature at which, that is the definition of absolute temperature. the temperature at which VIMS of molecule becomes zero. That temperature is known as absolute temperature. That known as absolute temperature. Again, the definition of absolute temperature is that the temperature for which VIMS of molecule becomes zero is known as the absolute temperature. Again, the average translational kinetic energy of 1 mole of gas is half mv square is equal to 3 by 2 kV into T. Now in this equation, kV is the Boltzmann constant, T is equal to absolute temperature, m is the mass of molecule of a gas, v is the speed of molecule. Now 2 to cancel, therefore average v square is equal to 3 kV T upon m, 2 to cancel. Therefore, taking the square root on both sides, so it gives the VIMS value. So VIMS is equal to under root of average v square is equal to under root of 3 kV T upon m. If the temperature T is equal to 0, then this term becomes 0. It means the VIMS becomes 0. From this condition, we define the absolute temperature like this way. The temperature at which VIMS of molecule becomes 0. That temperature is known as absolute temperature. After that, we are going to derive the equation of VIMS in terms of mass of the molecule. Obtain equation of VIMS in terms of mass of molecule of the gas. For that purpose, first we enter the equation of the average translational kinetic energy. The average translational kinetic energy of the molecule of a gas. The average translational kinetic energy of molecule of a gas is, there is the average half m v square is equal to 3 by 2 kV into T. Take them in this side to cancel, therefore average v square is equal to 3 kV T upon m. Taking square root on both sides, so we obtain VIMS is equal to therefore VIMS is equal to under root of average v square is equal to under root of 3 kV T upon m. Here, at given temperature, T and kV are constant. Therefore, VIMS proportional to the 1 upon under root of m. Thus, the VIMS of molecule of a gas is inversely proportional to the mass of the molecule. Thus, VIMS of molecule of a gas is inversely proportional to mass of a molecule. Mass of a molecule. So that is the important equation of VIMS, because frequently we are using in numerical. Right? Again, how we obtain the equation of the VIMS in terms of the mass of the molecule? For that purpose, the average translational kinetic energy of molecule of a gas is average half mv square is equal to 3 by 2 kb into t. To cancel, therefore average v square, take this m in this side, therefore 3 kb t upon a. Taking the square root on both sides, therefore VIMS is equal to under root of average v square is equal to under root of 3 kb t upon a. Here at given temperature 3 and kb are constant, therefore VIMS proportional to the 1 upon square root of m. Thus, VIMS of molecule of a gas is inversely proportional to the mass of a molecule. Now, the next equation of the VIMS in terms of the molar mass. So, question is that obtain equation of VIMS in terms of molar mass. Molar mass M0. That means we have to derive the equation of the VIMS for 1 mole of N gas. 1 mole of gas. For that purpose, we start from this equation, the average translational kinetic energy. The average translational kinetic energy of one molecule of a gas is half m v square is equal to 3 by 2 kb into t. But we know that kb is equal to r upon Na. But kb Boltzmann constant is equal to r upon Na. Here r is universal gas constant. In a, you get your number. You get your number. Take, substitute in this equation. Therefore, average half m v square is equal to 3 by 2. Kb is equal to r upon Na into. Take this Na in this side. Therefore, average half m v square into Na is equal to 3 by 2 RT. That is the average kinetic energy of 1 mole of gas. Because Na, number of molecule in 1 mole, and that is the half mv square. That is the average kinetic energy of 1 molecule. 1 molecule multiplied with the Avogadro number, that gives the number of molecule in 1 mole, is equation of average kinetic energy of 1 mole gas. 1 mole. So 2 cancel. Therefore, m into Na into average v square is equal to 3 by 2 RT. but m into Na is equal to m0 is equal to molar mass, the mass of 1 mole gas, molar mass. Therefore, m0 average square is equal to 3 by 2 R. Therefore, V square is equal to 2 to cancel, therefore only 3 RT. So 3 RT upon M0. Taking square root, that gives the VIMS is equal to under root of average V square is equal to under root of 3 RT upon M0. So from this equation, VIMS proportional to the 1 upon under root of M0. Thus, for 1 mole gas, VIMS is inversely proportional to the square root of molar mass. Molar mass. So there is another important equation of VIMS, right? So for one molecule, there is the inversely proportional to the mass of the molecule. Inversely proportional to the square root of mass of the molecule. For 1 mole gas, there is inversely proportional to the square root of mass of 1 mole of gas. So very easy. Only keep in mind that here, first write down the equation of the average translational kinetic energy of one molecule of a gas. Half m average square is equal to 3 by 2 kV into T. Now we know that the Boltzmann constant is equal to I upon Na. I is the universal gas constant. Na is the Avogadro number. Substituted here the value of kV. Therefore, average half mv square is equal to 3 by 2 R upon Na into T. Take the Na this side. Therefore, half average square into Na is equal to 3 by 2 RT. Now, average kinetic energy of 1 mole of gas is equal to 3 by 2 RT. For 1 molecule, there is the 3 by 2 kV into T. So this equation is the equation of average kinetic energy of 1 mole gas. Now m into Na, average square is equal to 3 RT to cancel, but m into Na is equal to m0. That is the mass of 1 mole of gas, that is known as the molar mass. Substituted here, therefore m0 average V square is equal to 3 RT. Therefore, V square is equal to 3 RT upon M0. Taking the square root, so VIMS is equal to under root of V square is equal to under root of 3 RT upon M0. Therefore, VIMS is inversely proportional to the 1 upon M0. Thus, for 1 mole gas, VIMS is inversely proportional to the square root of the molar mass. And third equation of the VIMS, we know that is the under root of 3p upon rho. We derive from the equation half mv square is equal to, the pressure P is equal to 3p 1/3 rho average V square from the equation of the pressure. Clear it? Now one more equation of the VIMS in terms of the pressure. Already we derived the two equations of the VIMS. First is in terms of the mass of the molecule, second is in terms of the molar mass, and now third is in terms of the pressure. Therefore, the obtained equation of VINS in terms of pressure P and density U. So where is the equation? So we know that the pressure, equation of the pressure P is equal to 1/3 rho V square. The equation of pressure P is equal to 1/3 rho average V square. Therefore, average V square is equal to 3P upon rho. Taking square root on both sides, taking square root on both sides. So this square root of average V square, that is known as the VINS, is equal to under root of 3P upon rho. 3P upon rho. So that is also important equation of the VINS. So total 3 equation of the VINS. That is quite different than the other earlier two, because earlier two is depends on the mass of either the mass of the molecule or the mass of the 1 mole of gas. But that is the independent of the mass. That is only depends on the pressure and density of a gas. Now the next numerical, that is most important, frequently asked. The numerical is that find the VIMS of nitrogen gas at 300 Kelvin temperature. Find VIMS of nitrogen gas at 300 Kelvin temperature. Find the VIMS of nitrogen gas at 300 Kelvin. The molar mass for nitrogen M0 is equal to 28 gram per mole. Here it is not mentioned. We have to find out the VIMS of 1 mole of nitrogen gas or molecule of a gas. For that purpose, we only find out the VIMS for single molecule of a nitrogen gas. Therefore, the equation of the VIMS of 1 molecule of nitrogen gas, the equation of VIMS for 1 molecule of nitrogen gas, 1 molecule of N2 gas is VIMS is equal to under root of 3 kBT upon small n. That is your equation 1. But here M is not given, M0 is given. M0 is given. Therefore, the mass of nitrogen molecule into molecule is M is equal to molar mass upon number of molecule in 1 mole, that means the Avogadro number. MCO divided by Na, that gives the mass of 1 molecule, right? So here the molar mass is given 28 gram, convert into the kg, minus 3. Now, Avogadro number 6.02 into 10 is to 23. Can we simplify it? We obtain 4.65 into 10 is to minus 26 kg. That is the mass of single molecule of nitrogen gas. Substitute this value, substitute in equation 1, Therefore, VIMS is equal to under root of 3 kb 1.38 into 10 is to minus 23. Temperature 300 Kelvin upon the mass M. Mass M is 4.65 into 10 is to minus 26. Thus, we obtain the value of VIMS is 516 meter per second. Check it, the answer. That is the VIMS of the root mean square speed of nitrogen molecule of a nitrogen gas at 300 Kelvin. So this type of the numerical frequently asked in either objective or 2 marks theoretical question. Find the VIMS of nitrogen gas at 300 Kelvin. The molar mass of nitrogen is given the 28 gram per mole. Now listen. That is given the 28 gram, we have to convert the kg. Right? Now, equation of the VIMS for one molecule of nitrogen gas is VIMS is equal to under root of 3 kBT upon small m. So first we require the mass of the nitrogen molecule is F is equal to M0 upon Na, M0 28 into 10 is to minus 3 upon 6.02 into 10 is to 23, that is the Avogadro number. So thus M0 is the mass of 1 mole of gas, that means the mass of the Na molecule of nitrogen. So divided by Na, that gives the mass of single molecule. So there is the 4.65 to 10 is to minus 26 kg. As we substitute all value in equation 1, so under root of 3, Boltzmann constant 1.38 into 10 is to minus 23 into 300 upon the mass of one molecule 4.65 into 10 is to minus 26. So as we simplify it, we obtain 516 meter per second. Clear this? So this way we can also calculate the VIMS of a molecule in numerical base.